So, good afternoon. I am Shehab Ibrahim. I'm here to present our research entitled Data Analysis of Water Supply in Iligan City. Now, for the team. So, yes, that is me. So, I am a associate professor in, I'm an associate professor in the Department of Information Technology. We also have Ma'am Mia Amortinamisan, also in the Information Technology Department. Ma'am Siti Nufaisa Pasandalan of the Department of English. Our Dean, Professor Lavillas, and Ma'am Jennifer Joyce Maulana of the Department of the Computer Science. Now, what is our problem? Problem is that there is actually of inadequacy of water supply in Iligan City. So what we are trying to solve is we want to determine the inadequacy of water supply in Iligan City, which can be translated to why is there an inadequacy of water supply in Iligan City. So our specific objectives is we want to determine the water supply provided by the water resources or the pumping station, and we also want to determine the water supply needed based on the population. So for the Iligan City Waterworks system, this is the unit that is mandated by Iligan City to provide a reliable and safe drinking water supply to the city of the Iligan. Now for our data, we asked for data from ICWS, and they have provided these features or these attributes. So we got the barangay data, which contains the number of the members connected, and also we have the pumping stations, the list of pumping stations and their locations. Well, the location actually, they just provided an image, no? And then we estimate this from this image. We estimate the location of this pumping station, and then save it in for our GIS visualization. And then we also got discharge in liters per second for every pumping station, and the barangays connected for every pumping station, such as this figure. So this is the pumping station, or the Hinaplanan pumping station, which provides us shows the barangays supplied, no? The number of barangays supplied and the list of the barangays supplied by that pumping station. Now, based from the ICWS data, we found out that there is only 30 out of 44 barangays that are supplied with water from ICWS, and most of these barangays that are not supplied by ICWS, these are what we call the hinterland barangays. So actually probably around 60% of, in terms of area size, are not supplied with water from the ICWS. We also got the data from the ICWS, the number of connected residents in every barangay. No? So not everybody actually, not every resident in barangays are connected to the ICWS. So there are just percentage of residents in every barangay that are connected to the ICWS. So the Tubod actually has the highest number of residents that are connected to the barangay, while the Abuno has the lowest, which only has 91. The Tubod has 23,954, and the Upper Hinaplanon only has 441 connected residents. Again, these are not the total population of every barangay. No, a portion of the population in every barangay are connected to the ICWS. The others actually have their own ano na siya tawag na, home pumping stations, or personal pumping stations. Also, we were provided by the ICWS the discharge or liters per second for every pumping station. So as you can see, there are 10 pumping stations. So we have the Hinaplanon pumping station, the Abaga 2, Abaga 3 and 4, Ditokalan Spring Source 1, Ditokalan Spring Source 2, and Ditokalan Spring Source 3, Pangpang, Matuog, Anahawon, and the San Roque. So the Abaga 3 and 4 actually has the highest discharge, which is 567.75 liters per second, while the Anahawon only has 2 liters per second. Yes. And also we have from the ICWS, we also got the number of barangays supplied for every pumping stations. So the Hinaplanon serves 7 pumping stations. The Abaga 3 and 4 serves 15 pumping stations. We also have the Ditokalan and Spring Source 1, Ditokalan Spring Source 2, and the other spring sources. Now, in this figure or in this visual, we have the barangay indicating its connected pumping station and showing the size of the connected members. So for the x-axis, we have the number of connected members, and the y-axis and the barangay. And the colors of this bar represents the connected pumping station. For instance, the Tubod. The Tubod has the highest number connected members. Pero in the Tubod area or the Tubod barangay, there are 2 connected pumping stations. These are the San Roque pumping station and the Ditokalan Spring Source 2. For the Villa Verde, there's only 1 connected pumping station, which is the San Roque. For the Santa Rosario, there are 3 connected pumping stations: the San Roque, the Ditokalan Spring Source 1, and we also have the Hinaplanon pumping station. Now, we also downloaded geographical data from the GADM, or I don't know how to pronounce this, gadm.org. So we were able to download the shape files or the polygon files of every barangays in Iligan City. So this is what we use in projecting it in our geographical information system. So the GADM will give you multi-polygon or polygons for every barangay. Now these polygons contain actually multiple points in every sides of the polygon, or every point in the polygon. Now, we also took the average household size of barangays in Iligan City. We got this from the psa.gov.ph. So, as you can see, the average household size. Now, this is still on 2015 because there is no record of average household size beyond 2015. So the barangay that has the highest household size or largest household size is actually the San Miguel, which is more than 5, and the upper Hinaplanon has the lowest, which is lower than 2. Now, again, as I've mentioned, the resident that is connected to ICWS is just a portion of the total population of that barangay. So from this figure, we can see that not 100% are connected to the ICWS. Such as in Abuno, only 21 households are connected compared to 1,258 households in the census data. from the psa.gov.ph, no? So only a portion of it are connected. Actually, only a portion of the residents in every barangay are connected to the ICWS. Now, again, this data was provided to us by the ICWS. This shows the routes of the water tubes and the location of the pumping stations. So what we did here is that since there is no exact location provided to us, it's just a figure, we estimate this, and we got the latitude and longitude of every pumping station by estimating its location based on this figure. Now, there is this term called non-revenue water. This is from the ICWS data. What is this non-revenue water? These are the portion or the percentage that is unaccounted, because according to their computation, the total water supply of all pumping stations is 168,709 cubic meter per day, or equivalent to 168.709 million liters per day. But then, the only total billed volume is just around 59,048 cubic meter per day, or 59.048 million liters per day. So there's this difference, or unaccounted 97,091 cubic meter per day, or 64% of the water supply are unaccounted. They don't know what happened or where the water goes, and they term this non-revenue water. So probably the cause of this are leakages from the water tubes, and also the illegal tappers or illegal connectors to the tubes of the ICWS. So there is this 64% non-revenue water. Now, how did we deal with the barangays with multiple stations connected? Now, because we have to project this into the GIS. So suppose we have this polygon of the Hinaplanon. This is what the Hinaplanon looks like. Now, the Hinaplanon, it has a number of connections or number of household connected to ICWS of 2,242. Now, the average household size based on census of Hinaplanon is 4.0989. So we were able to determine the number of connected members in that barangay, which is, in this case, it is 9,189 connected members. Now, what we did here is that since for this instance, Hinaplanon, actually, there are 3 pumping stations connected to this barangay. These are the San Roque Pumping Station, Litocalan Spring Source 1, and Hinaplanon Pumping Station. So what we did here is we use an algorithm or a code that will divide equally the polygon. Okay, and then we term this Hinaplanon Area 1, Hinaplanon Area 2, and Hinaplanon Area 3. Because we cannot get the actual division of this area because this was not provided by the ICWS. What we did here is we did just estimations. We equally divide the polygon into 3, or into the number of the pumping stations connected. Okay, and then also we divide equally the connected members. So we assume that there is 3,063 connected members for the Hinaplanon Area 1, 3,063 connected members for the Hinaplanon Area 2, and 3,063 connected members for Hinaplanon Area 3. Now, for the pumping stations that connects to multiple barangays, so for instance, we have the Litocalan Spring Source 2, which has a discharge of 252 liters per second. So excuse me, excuse me. So what we did here is that we divided equally also based on the number of the barangays connected to it. So in this case, the Ditokalan Spring Source 2 is serving 3 barangays, the Tubod Area 1, Tuminobo Proper Area 1, and the Buroon. So the discharge is equally divided to these 3 areas. So each area got 84 liters per second. 84 liters per second. Now, how did we come up with the average water supply or the liters per day of the barangay? Okay, so this is the formula that we have formulated or have created. So on this on the numerator portion, we have the discharge or liters per second of the pumping station over the number of barangays supplied of the pumping station. This was discussed on the from the previous slide, and then multiplied it by 60 to convert it to minute per second, and then we multiply it again by 60 to convert it to hours per second, and then we multiply it by 24 to convert it to day. Okay, to day. And what I mean is liters per minute, and then liters per hour, and then liters per day. And then we multiply it by 36.36. Now, where does this 0.36 comes from? As mentioned, there is this 64% non-revenue water, or 64% are unaccounted. So there is only 36% accounted, which means that 64% probably are losses because of the leaks or leakages and all the illegal tappers or connectors. So that is why it is multiplied by 0.36. And divided this on the denominator side, we have the number of connections in the barangay multiplied by the average household size. So this gives you the number of connected members, and then over the number of pumping stations in the barangay. This equates to the average water supply or liters per day of that barangay. Now, how did we get the route from the pumping station to a barangay? Okay, so first is we get the geolocation or the latitude longitude of the pumping station, which we estimate it based from the ICWS image that they have provided, and then we get the centroid of the barangay area. After getting this, we have now the 2 points, the source and the destination, and we run the a method from OSMNX or OSMNX. Forgot the term for the OSMNX. Which is the OSMNX.Dijkstra_path. This gets the shortest path from the source to the destination. In this case, from the PS to the centroid area of the barangay, using the street route. Again, we used this formula because the exact route was not provided to us, but they mentioned that the routes or the water tubes are following the street layouts. Now, it so happened that the OpenStreetMap has this data for all of the streets in the Philippines, and then when you run the Dijkstra path, it will follow also the street layout. So that is how we got the route from a pumping station to a barangay. Now, using the formula that I have mentioned of the water supply per day, we found out that probably around 40% or 30% are undersupplied, no? So starting from Tipanoy, Palau Area 1, Santiago, Suarez, Luinab, Tambacan, San Roque, Santa Elena, Tubod Area 2, Del Carmen, Tubod Area 1, Dalipuga Area 3. And the rest actually are hinterland barangays that was not provided or were not provided by the ICWS. Now, based on the actual consumption from the ICWS data, they have come up with the standard for the consumption of water in liters per second per person is 260. So below that value is what we call undersupplied or underserved. So these are the barangays that have values below or under 260. And we call these are the undersupplied barangays. Now, another figure that we have created is this, the daily water supply in liters per second per household member for every barangay. Okay. On the x-axis is your daily water supply in liters per household member. And in the y-axis, we have the barangay. The colors pertain to the pumping station that serves the barangay. The good thing about this visual is that it gives you the overview picture of the relationship between barangay, pumping station, and its water supply. No? For example, the Abuno. Abuno has a water, every resident or every connected member in Abuno is receiving 13,067 liters per day, which is very big actually, very high actually. And in Abuno, this is served by the Abaga 3 and 4, the pumping station. So there's only one pumping station in Abuno, which this is the Abaga 3 and 4. Let's go with the Dalipuga. In the Dalipuga, there are 3 pumping stations. And there are 3 pumping stations that are serving this barangay. These are the Abaga 3 and 4, Anahawon Spring, and San Roque pumping station. And we can also see the daily water supply, which is in the first area. It has 1,557. Every household member is receiving 1,557 liters per day. And the other area is 82.28, and the other area is 519.05. Now, again, only 20% actually of the Iligan area size is connected to ICWS. Only 20%. And only 44% of Iligan City's total population is connected to the ICWS. Well, the reason for this is most of the residents in Iligan City are not dependent with the ICWS. They have their own personal, they have their own motor pumps, no? And some of these areas actually are river nearby, and they prefer this natural water sources than connecting to ICWS. Now, in this visual, these are the dots actually represents the barangay areas, and at the x-axis we have the water supply liters per day, and the y-axis is the length of water tubes in meters, the length of water tubes in meters, and the colors represents the pumping station. Now, the insight that we can get from here, and also the y-axis, the y line, the vertical line actually separates the undersupplied barangays area over the from the well-supplied barangay areas. No, so the left side of this blue line are undersupplied barangay areas. Now, one of the insight that we can see here is that we are able to see that for the Hinaplanon pumping station and the Ditocalan Spring Source 1, they have been providing undersupply water to almost half of its connected barangays. No? Half of its connected barangays. We can also see that the Abaga 2 spring source, which is connected actually into that actually serves one barangay only, is providing also undersupply water to its barangay. No? And another insight also that we can get from this visual is that there is no well, at least for this case, at least for this paragraph, for this visual, there is no correlation between the length of water tubes in meter over the water supply liters per day. I cannot really say if this is true because, well, if you have a longer water tube, this is more prone to leakages or probably possibly connected by an illegal tapper. No, so I do believe, contrary on what this visual shows, I do believe that the length of water tubes can affect the water supply in liters, water supply in liters per day. Now it can really affect because again, it is more prone to water leakages and more prone to being connected by an illegal tapper. This is the point that I'm going to show now one of our maps or the GIS maps that we have created. Okay. Let me just change window. Yeah, this one. Okay. This is this is a GIS map or a geographical information system map that shows the map of the Iligan city and also shows the location of the pumping station. There are again 10 pumping stations. So as you can see, the three Ditocalan spring sources are located in Ditocalan. The Pampang spring source is located in the Maria Cristina. The Abaga 3 and 4 and Abaga 2 spring source is located in Suarez. The Hinaplanon pumping station is connected or located in the Upper Hinaplanon barangay. The San Roque, of course, is located in San Roque. The Matuog is located in the Akmak area or Akmak barangay, and Anahawon is located in the Dalipuga. And also it shows the routes. It shows the routes. Again, these routes are result of the method from the OSMNX, which is the getting the shortest path from one point to another. And the chloroplet or the colors of this polygon represents the level of the water supply. Now, such as Abuno actually has the highest water supply, so it has the darkest color. This portion here has pretty good water supplies, and then Del Carmen. Now, the Del Carmen is actually undersupplied. The Tubod area 1 is undersupplied. Also, the Tubod area 2 is undersupplied. Suarez is actually undersupplied because our standard or our baseline is 260 liters per day. Okay. Now, going back to our presentation. Yes. Oh, okay. So we actually also have for this. We actually also have uh, pumping stations or maps for every pumping station. So in this case, this is the San Roque pumping station. So as you can see, San Roque is here, no? And it serves 5 barangays: the Santa Filomena, the San Roque, the Akmak Area 3, Kiwalan Area 3, and Delipuga Area 3. Now, the most glaring, or the first question you have in mind right now probably is that, why is there a barangay that is connected to San Roque, but it is much closer to another pumping station, no? Such as Dalipuga Area 2. This Dalipuga Area 2 is connected to this station, but then there's actually a pumping station very close to Dalipuga. Well, probably the answer for this is that San Roque is one of the oldest pumping station, and these pumping stations are just new. Now, during that time, this barangay really need to connect to a pumping station, and probably at the time, the most nearby or the most closest pumping station is the San Roque. So they have to connect to San Roque. Now, when this new pumping station comes up or props up, probably the ICWS or the Iligan City doesn't have the resources yet for this barangay to be transferred to these new pumping stations. Same case as with the Abaga 3 and 4. Look at this. Abaga 3 and 4 is found in Suarez. But then, it is also serving the Dalipuga area. The distance between Suarez and Dalipuga area is actually 20 kilometers, which means that the water tube from this Abaga 3 and 4 to Dalipuga is around 20 kilometers also. And there's actually a very close or very near spring source here, is the Anahawan. Again, Abaga 3 and 4 is one of the oldest pumping station, and during the time this barangay really needs to connect to a pumping station, then they were forcibly connected to this spring source. And when this new pumping station comes up, probably they don't have the resources yet for these barangays to transfer to the new or closer pumping station. Now, going back, so another visual here is the water supply in liters per day of heat map from every pumping station to every barangay. On the x-axis is the pumping stations, and the y-axis are the barangay. Now, the intersection of this axis or the cell are the water supplies. So you may be wondering, what if we transfer a barangay area to another more suitable pumping station that will provide a higher water supply? So that is the purpose of this visual, no? So what we have found out is that only Dito Calan, Santa Filomena Area 2, Suarez, Tominobo Proper Area 1, and Upper Hinaplanon have the ideal connected pumping station, while the rest could have a higher water supply if connected to its ideal pumping station. For instance, in Akmak Area 1 is currently connected to Abaga 3 and 4 spring source, which has a water supply of 270 liters per day. But if the Akmak Area 1 is connected to Dito Calan Spring Source 3, it will have a water supply of 900 liters per day. Another, the Santa Filomena Area 1. The Santa Filomena Area 1 is also connected to Abaga 3 and 4, which has a water supply of 260. But if this area be transferred to Dito Calan Spring Source 3, it will have a water supply of 850 liters per day. Okay. Another visual here is the heat map of the distance. Now, instead of water supply, we project the heat map of the distance. Now, we found out that only around 25% of the barangay areas are connected to their ideal pumping station in terms of distance. What does this mean? What does this mean? Ideally, barangays should be connected to the nearest pumping station, but only 25% of these barangay areas are connected to its nearest pumping station. Around 75% are not. No? So which obviously longer distance water tubes means more prone to leakages. So for instance, the Lipuga Area 2. The Lipuga Area 2 is currently connected to San Roque Pumping Station. So the Lipuga Area 2 is connected to San Roque Pumping Station, which has meters of 8,100 meters or 8 kilometers. But then the Lipuga Area 2 is very much closer to Anahaon, which is just 19 meters. Estimated 19 meters, no? So why is it that the Lipuga Area 2 is connected to San Roque Pumping Station, which is 8,000 kilometers, 8 kilometers away, where in fact there is this pumping station that is closer to this barangay, which is just 19 meters away. So this is what that is the purpose. That is the purpose of this visual. Now, what if we account all the population, the total population of every barangay? So what if the total population of every barangay connects to the ICWS? Well, obviously, it will produce more under supply barangay areas. So what we did here is we created a simple formula that will determine the minimum water supply to prevent undersupply of all barangays. So what we have found out is we need to increase the discharge of Abaga 3 and 4 spring source from 567 to 2,120 liters per second. The Anahawan spring source from 2 liters per second to 62. Ditukalan from 252 to 706. Hinaplanon pumping station from 208 to 331. Pangpang from 41 to 50, and San Roque from 82 to 310. If this discharge of every pumping station will be increased, there will be no undersupply in all barangays. Yeah. So what are the insights or takeaways? No, water supply is more than daily needs of those with water connection to ICWS. Shortage of water of those with the water connection is largely due to the non-revenue water, which is around 64%. Hinterland barangays are not connected to ICWS, and then multiple barangays have more connections than their need. Possible recommendation to government agencies or stakeholders: the improvement of ICWS connections, repair and maintenance of connections pipes to lessen the non-revenue water, and the opening delivery of water services to private entities, and conduct a validation of data by an external entity. And hinterland barangay should also be connected to ICWS. That is actually the end of our presentation. But then before I end this, I would like to show the website that we have created or a web application that we have created that is hosted in a Google site. So we actually have this, sorry. So we created this. This is where we upload all our visuals in the site. So we have the home, barangay analysis, okay, pumping station analysis, this one, okay, and then every pumping station also is here, and then also their corresponding charts, every pumping stations, and then we also have the further analysis. So you can we can provide this link if you want to have an access for this site. Thank you so much for listening.